All right. Sorry. Whenever I record AP, Bisky just yells, "Hi guys!" Like the moment that counts down to 1. Who knows Bisky? Does that surprise you? not, not one bit. I love that man. All right. There's still a lot of iPads out. As you finish your quiz, just go ahead and tuck them in. We are averaging a 82%, so that's pretty good. And like a couple of those, and I'm not picking on you personally, but they put 1s, which is still right, but my key didn't have 1s. All right? Some people put the metal and the non-metal backwards, and they got it all right, but they get it all wrong. So overall, I think we're okay with this. Do you feel okay with this? Okay, good. All right, so we've done that. So the rest of the day, notes on covalent bonds. Did we start these at all? Yeah, but we'll find out. Page 8, I think. I hear a no and a yeah. Kind of. What? All right. Well, let's do this then. Oh, I had 5 more minutes, I thought, but I didn't. I have some dope skills. What? You what? Thank you. You're always looking away. The worst I've ever done is a pencil that I hacky-sacked right into my eye, which wasn't as bad as something I did in college. This is maybe one of the dumbest things I ever did. So I am a male, which means when we are around females, we do stupid things. Who's noticed that, girls and boys? So I was showing off, and I was like, hey, look. I can snap the lead off of the top of that pencil with a towel, which I could. It's not standing up. Hold on. All right, so pretend that it's pointing that way. And I was like in this dorm room with these girls. And I'm like, hey, they'll think I'm cute. I don't know what boys think. We're morons. So I wind the towel up, and I snap the pencil. And I'd done it before, but I'd never done this before. The towel like wraps around this and rips it out between the 2 books, and it flies, and it goes right here and sticks into my eyebrow, just like, I'm like, oh, and then I had a little bit of blood. I'm like, okay, I'll never make out with any of them. That was pretty cool. If I was in college, I would think, oh, hey, they'll all like me, because I flipped my pencil and it landed on my desk. Which I know is stupid now. I know that you don't care. I don't know why I'm whispering. Okay. Remind me to delete the first 3 minutes of this recording, because it's pretty much pointless. All right, so our ionic formula quiz went great, I'm sure. Now we're talking covalent. I'm pumped. Yay! I wanted it to do that, in fact. Uno momento, por favor. There we go. Now we're good. No, what the? Okay, let's try it. Why are you laughing at me? I know why you're laughing. You're like, this is so uncomfortable and he's in a good mood. Let's get him mad and see what happens. Mother freaking of pearl. All right, remind me to delete the first 4 minutes of this video. And ready, set, hey, do you know ionic bonds are not covalent bonds? Because they have 2 different names. Beat that horse to death, didn't I? That's probably not a saying anymore. It's not animal cruelty. I apologize. Move on. Covalent bonds. This can't be where we are. Is this? Boom, boom, boom. Hold on. Wait for it. Get my crap together. All right. A covalent bond is different than an ionic bond. Let's say any of that right. Atoms with the same or nearly the same electronegativities tend to react by sharing electrons. I know that's a giant word for a small box, but life's hard. All right, will you quickly tell your lab partner what electronegativity is? All right. So just real quick, it's the hotness factor. Thank you, front corner. All right. Greer just kind of looked at me like, it's a thing. It's something you learned while I was gone, right? You were supposed to learn while I was gone, right? Is that better? Electronegativity is the ability of an atom to attract electrons to it when it's in a bond. So what we're saying, in an ionic bond, the difference in electronegativity is so big that the metal will lose its electron to the nonmetal. But in a covalent bond, the difference is not big enough to completely remove an electron. So what do they have to do? It's underlined. They have to share instead. Sharing is caring. Thank you. Now, it's sort of easy to understand that covalent bonds share if you realize the word co means together. Did you know that? Well, thank you. There you go. Covalent means your valence electrons are together. You share them together between the two atoms. Good? All right. Hey, there's the plan for today in the wrong space, but whatevs. The shared pair or pairs of electrons constitute a covalent bond. So why won't this work? I'm awfully confused. It worked first hour. All right. So just the simplest example of a covalent bond is the diatomic molecule of hydrogen. Hydrogen, first off, is a nonmetal. Do we all know that? I hope. It has one valence electron because it lives in family 1. It wants 2 because for it to get to family 8, it needs to be like helium, correct? So it will find another hydrogen and they will share that pair of electrons. And that way, both of them have a full 1s bonds. Because it's a 1s with a 1, and it's a 1s with a 1. And they overlap, and then they're full. You with me? Fluorine is the same way. It just is in family 7. 1, 2, 3, 4, 5, 6, 7. It will find another fluorine, 1. They share. Then 2, 3, 4, 5, 6, 7, and it's 1. And now fluorine has 8, and this fluorine has 8. So together, neither one of them has a full octet, but if they share a pair, they will. You didn't understand it? The last blank? I can go back. I would love to, in fact. I need to take a breath. Sometimes I lose my breath teaching, and it is embarrassing. That means I'm super out of shape. I am standing here, and I lose my breath. And I'm a track coach. Oh. All right, are we? All right, how? All right. Usually, and for us it will always, this occurs between nonmetal atoms. And they are bonds with differences in electronegativity that are less than 1.7. Now, I don't remember what hours I did this or not, but will you all make sure that you have this and you've looked on this right side? The values of your electronegativities are listed right there. Will you underline them or circle? So ionic, greater than 1.7. Polar, between 1.7 and 0.6. And then the other one is less than 0.6. Circle those so you realize that we don't need that graph anymore. We just need to look on my periodic table and realize those values are listed. So yesterday, I think this was the hour where every single person got every single thing right. Wasn't every single thing, but at least one problem we all got one right. We all got it right. So that means everyone, and I know one or two of you weren't here, but we know how to calculate this, is what I'm saying. We can find the answer, the math answer, and now we know it's listed on the periodic table. Those should be just pretty much free questions on the test. All right, so they occur between nonmetals and are less than 1.7. All right, there can be a sharing of 1, 2, or 3 pairs of electrons in a covalent bond. And I'll kind of draw these out to explain a little bit. But remember, every nonmetal's goal is to achieve an octet, and so to do that once in a while, they have to share more than just a pair. All right, so here we go. Once again, I will use the diatomic molecules, and that's a word maybe you don't remember because it was for forever ago. But if you'll look right here, you should have a 2, and it says diatomic. Does everyone have that on there? Do you have it on there? That'd be a bit. Ooh, I was close. About right there. Does everyone have a 2? Check your lab partner, make sure you have a 2, and it means diatomic on this side. Now, if you got a new periodic table, you're obviously not going to have that, so you should add it. Don't stress about this right now. Stress about these. All right, so we've had that 2 on our paper forever, and we just told you, hey, that means when you put 1, there's 2. Well, the reason why, once again, is because of this octet rule. So we said, I'm going to do fluorine again. I'm going to do oxygen, and then I'm going to do nitrogen. So fluorine has 7, correct? 1, 2, 3, 4, 5, 6, 7. This fluorine, 1, 2, 3, 4, 5, 6, 7. So they share a pair. I'm going to teach you a tiny bit of math that you don't have to ever know on a test, but it will hopefully help this make sense. How many did each fluorine have individually? 7, but there's 2 of them. So fluorine itself has 14 valence electrons, the 2 of them. Is that okay? Yeah. All right, thank you. To achieve an octet, though, for 2 things, what number do you need?
8.
No. Times 2. You need 16, right? So look, if you take 16, you minus, and you get a 2. That 2 tells you they share 1 pair of electrons. All right, let's do oxygen. Oxygen is O with 6 dots, correct? 1, 2, 3, 4, 5, 6. I don't like how I wrote that. How about 1, 2, 3, 4, 5, 6? Just trust me. So it's short 2, correct? I'm going to put another oxygen right here. 1, 2, 3, 4, 5, 6. If you'll look, how many valence electrons does that oxygen have? 8. Be less bored. Sounding, at least. How many does that have? 8. 8. Thank you. So math, 8 plus 8 is what number? 16. But does it really have that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No. It's 4. So how many electrons do they need to share? 4. Thank you. Thank you over there. Roach, are you lost?
No.
Are you tired? I can tell. That was rude. Not you look great, but you're like, okay. That was rude. I'm fired. Yeah. You pretty much look trash. All right. So we share 4. Remember, when we drew the things, a pair meant a line. Now, nitrogen, N2, it has 5 valence electrons. What's 5 times 2? 10. So there are 10 total electrons, but it needs 16. So that means it has to share 6. Thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Octet. Octet. That just shows being agreeable. Doesn't mean you get it all the time. I was illustrating, in case anyone else is like, what is this? I was illustrating that in a covalent bond, you can share 1, 2, or 3 pairs of electrons. You can technically share 4 between carbon and carbon, and that makes stuff like diamond. But we don't experiment with diamonds very often. That'd be sweet if we could afford that. All right. Yesterday we drew some dot structures of carbon dioxide, which was CO2. And we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I don't think I counted that right, but whatever. We octeted everything by sharing 2 pairs twice. Now look, if you didn't get what I just said, it's acceptable as long as you know they are sharing pairs of electrons in a covalent bond. Question, Clip?
How long does it take to make a diamond?
Well, that depends on the energy you can put in. It takes thousands of years, or it in a lab takes probably a couple of weeks. They can make synthetic diamonds now, and they look exactly the same and do everything the same, but they're not natural, so they're not expensive. No, they put them in giant. Have you guys ever seen like an egg barbecue smoker? Okay, Floss, thank you. They look a lot like that. They get a ton of pressure, a lot of heat, and you can make carbon into diamonds. Now, it is a thing, but look, how do you tell them apart? You can't. When I bought my wife's diamond, you get a piece of paper that says, "This is real." You're like, thank you. I paid $2,500 for a piece of paper. But they guarantee that it's real and all that. You can't tell them apart. If I were you, I would buy a cheap one and lie to my wife my entire marriage.
Sounds like a good idea. Hey, good thing you have this recorded.
But I didn't. Hi, Melanie. All right. No, one of the best things that ever happened to me was my wife watched a documentary on blood diamonds, and she's like, "If you ever buy me a real diamond again, I will divorce you." I was like, "Sweet. Fake diamonds the rest of our marriage. This is perfect." So anyway, if you don't know what a blood or a conflict diamond is, you don't want to know. All right, hey, this is a covalent bond because they're sharing a pair of electrons, right? Oh, yeah, I'm recording. Was that not good to record? It's good enough. All right, a sharing of 2 pair, a share of 3 pair. All right, so here we go. I'm now going to talk to you about polar covalent bonds. So what you need to know, I may have said this before. I say a lot of things in some classes and nothing in others, but whatever. Here we go. There are essentially 2 types of bonds that we're learning about. And they are ionic and covalent. But we're going to teach you 3, and the reason there's 3 is because covalent itself has 2 types, polar and nonpolar. All right, so for the majority of the rest of the hour, we're going to talk about polar covalent things. I don't want to know. Okay. So, a polar, well, hold on, where'd it go? So here we go. No 2 elements have exactly the same electronegativity unless they are the same element. Will you one more time explain to your lab partner what electronegativity is? Ready, set, wake up, and go. All right, maybe. Like it started well and kind of tailed out towards the end. It's like every work project at my house ever. All right. Electronegativity, one more time, and I'll probably keep saying it, is the ability of an atom to attract electrons to itself, or its hotness factor. If it's better looking, the electrons will go to it. If it's ugly, it won't. Sorry. Welcome to life. All right, now, To illustrate this, I'm going to tell you a story from my life. I know what you're thinking. We're not going there. I was the hottest friend I had. You just design it that way. You always hang out with ugly people. Then you're always the best looking of the ones you hang out with. It's a piece of cake. All right. All right. These are two people in my life that I know well. Do you know who they are? Melanie. I am not married to my sister. Oh, I gave that away, didn't I? So this, what? You're just, when I was a sophomore, my sister was a senior. Those were our grades. All right. And when I turned 16, it was a great day. I got my driver's license, and my mom said, awesome, now you and Amanda can share a car. Oh, why did you make that noise?
That sucks.
Because it sucks. Why, Raquel?
I don't know.
What? What?
Brings your hotness down.
Okay, it did bring my hotness down. We were driving a station wagon too, so like it was more like it took my coldness down. But has anyone ever had to share a car with an older sibling?
No.
You did. Thank you. How did it work out? No, Isabel.
It sucks.
It sucks. How come?
Because I just don't like being with them, so.
Oh, you guys are failing this.
But you fight over the car.
Because you fight over the car.
I don't even know either.
So if we had, if there was 180 school days my sophomore year, I got the car at least one of them that I can remember. So we shared a car according to my mom. We shared a car according to the definition of you guys will both have access to it. But did we share the car?
No.
We didn't.
It was Amanda.
In a polar bond, they don't share either. They share, but one almost always has the electron with it and the other one doesn't. And it creates what we call a polar bond. Now, just a brief statement about the one day I know I got it. You know how I got it? I stole it. I took the keys, and she had no idea until she went to go to lunch, and the car wasn't there. And so she called my mom. Do you know where Tom is? He's not at school today. And my mom said, I'm pretty sure he is. I'll call the school. Well, the problem was I was at Brighton skiing. The greatest snow day of my life. The canyon had been closed for 3 days, and there was 55 inches of powder. It would have been illegal for me to go to school on a day like that. I had to go skiing. The problem was I made a giant mistake that day, besides that my sister Amanda existed, which, bless her heart, I love her. But I went skiing with her boyfriend. So not only was the car not there at lunch, neither was her boyfriend. And you know what? She knew where I was. She called my mom, so my mom would call the school so that I would get in trouble. I went to school in a 7-period day. I got 7 U's, each worth 8 hours of community service for that day. I don't do math well. Is that 56?
Yeah.
That's 56 hours of community service I got. How come?
Because you went skiing.
Because I went skiing, I took the car, and we shared this stupid vehicle. All right? Now, when I was a junior, I shared it with no one. And I went skiing a lot. From my house to go to Skyline, you go up a road and take a left. If you go up that road and accidentally keep going straight, you arrive at Brighton. My fault. The sun is in your eyes in the morning, and you can't tell that you didn't turn left, and that your skis, jacket, boots, poles, and everything else was in the back of your car. I don't know how that happened. But I never got turned in because I didn't have to share when I was a junior. But all right, so we sort of shared the car. Are you with me on the idea here? In a polar bond, they sort of share what thing? An electron. An electron has a what charge? A negative charge. And so if part of the molecule is more attractive to the electron, that part of the electron will be slightly more what? Anyone know besides post? No, negative. So if one side's more negative, then that means what about the other side? It's more positive. And if we have something that has a positive and a negative half, we call it a polar substance. A magnet is polar. Our planet is polar. It has a north and a south pole, right? It's because it creates two halves of things with opposite charge. Charges, I mean, not charge. All right, so here we go. You are going to draw a picture, just anywhere on the, how about the bottom right of page 8? All right, and have your best shading skills of your entire life. I don't know where it is, but it's coming up eventually. Oh, I skipped some notes, whatever. Draw that picture right there. Now notice, you're going to shade around this one on the left and not shade around the one on the right all the way. You can. That is true they're different sizes, but in this class it doesn't matter. We're going to shut the door. That's what we're going to do. All right. Oh, I can see we have some future artists. So I will give you more time. You almost failed. All right. Now, I guess technically, real quick, let's do the blanks and we'll come right back to this picture. I didn't realize. Here we go. Because of this, when covalent bonds form between different atoms, one of the atoms more strongly attracts the valence electrons of the other. And we said that, I just didn't show that. So we're going to have the electrons move from one place to the other. What time are we out of here? 6 minutes? I got to fly. Woo, here we go. All right, this unequal sharing of electrons causes one atom to be more negatively charged and the other more positively charged, resulting in a polar bond. All right, so here you go. This will be the weirdest quiz of your life. This picture that you just drew, I want you to label Tom and Amanda. Don't say it out loud. Which circle represents me? Which circle represents Amanda? And what is the fuzz representing? The car. Nice job. And really, you do it. Very good eye for shading. This is being recorded. Ooh. All right, so here we go. As I walked around, besides that Willow can draw circles like no one else. All right, I noticed that most of you had this absolutely right. Which atom represents me? The right one or the blue one? This is Tom. And then green must be Amanda. And you'll notice that this is sort of representing how often we had a car. Now, that would be the summer when she was asleep and I could get the car before she left. Eventually, actually, Amanda bought her own car, which she should never have done. Went into huge debt. Long story. Won't go there. All right. So far, we sort of all right here. Now, in this picture, will you also label, here we go. I made this right here. We are labeling Amanda and Tom. Check. We did it. will you also label which side is positive, which side is negative? Because now, if we're not talking about the car, because that's not what chemistry shares, it shares the electron. So talk with your lab partner and label which side here would have a plus or a minus. A little bit harder.
Plus side is a minus.
You want me to look? Some kids get scared. Because the car is the negative electron. All right, here we go. Now, as far as personal attitudes, this is labeled the wrong way. She's way nicer than I am. All right, Amanda would be the negative, right? Because the electrons are around her more than they are me, which is the positive side. You okay with that? Okay, now the last thing we're going to label is, behind this movie, label which atom is more electronegative, which is less electronegative. Electronegative. I've tried to prepare you for this question all day by repeating. Electronegativity is the ability to attract an electron to itself. So since we're sort of crunched on time, which one is more electronegative? Amanda. And which, oh my, I keep doing that. And then mine must be left. Now I'm not done yet. More and less. I have one more example. I have a picture that I'm going to show you of the counter in my bathroom. Which I do what? Which I share with my wonderful, gorgeous, beautiful wife. Will you have a conversation about how this picture illustrates a polar type of sharing, where we share but unequal? To help you maybe visualize, I will circle everything in this picture that's mine. Okay. Now, continue with your conversation. How is this polar? What do we think? Do we understand that this is polar? Because look, we are sharing this space. But I don't even occupy counter space. I am on the edge of the counter to give her as much space as she needs. Now, technically, I do use anti-cavity oral rinse, so we share that. Anti-cavity oral rinse. Mouthwash. I guess we're done. Goodbye.